Welcome back. Um, Hi everyone. My name is Mwiza Chirwa. In this video, I will take you through the third part of acid and base. So let us look at the success criteria that we are going to cover by the end of this lesson. So the success criteria that we're going to cover by the end of this lesson are as follows. We are supposed to determine the strength of acid and bases using universal indicator and pH scale and explain the applications of neutralization reaction. So everyone by the end of this lesson is supposed to achieve those objectives. So let us start looking at the strength of acid and bases. So the word strength of acid and bases, we are looking at what comes in our mind is that it means others are weak as well as others are strong. So acids and bases are grouped into either strong or weak acids or bases. Examples of strong and weak acids. So here in a table, we have example of strong acids and weak acids. So we have on the strong side, we have hydrochloric acid, nitric acid, sulfuric acid, and phosphoric acid. These are strong acids. In weak acids, we have ethanoic acid, which is also known as acetic acid, methanoic acid, carbonic acid, citric acid, as well as lactic acid. These are examples of weak acid. So we need to look at the difference between strong as well as weak acid. So the following questions will help us through to know how can we know that this one is a strong acid or weak acid. So we have the following questions. What is the difference between strong and weak acid? And what makes an acid to be strong or weak? These two questions are the same and can be answered at the same time. So strong acids are acids which ionize completely in water by giving out all its hydrogen atoms, while weak acid does not ionize completely when dissolved in water. It means some of the hydrogen remain with the acid. Note, the strength of an acid should not be confused with concentration. Concentration, we can define concentration as amount of solute present in a solvent. So if we have higher proportion of an acid in water, it means the solution that is going to be formed is highly concentrated because now we have higher proportion of solute. But if we have low amount of acid in water, it means the concentration of the solution that is going to be formed is weak. So these words, strength as well as concentration, are usually confusing in terms when we want to use them. So in summary on the questions, maybe if we want to differentiate it, when we are looking at strength, we are looking at the ability of an acid to ionize in water. When we are looking at concentration, we are looking at now the amount of the acid present in water. So this is the difference. So if a question comes, can you differentiate between the strength of an acid and concentration? First thing to come in your mind should be on a strength, we are looking about the ability of an acid to ionize in water, while concentration, we are looking now at the amount of the acid in water. So now we'll go back on how can we know and how can we determine the strength of an acid and base. That's why here we're saying how to test the strength of an acid and a base. So some of the ways we use to test the strength of an acid and base are as follows. We use a pH meter, a universal indicator and a pH scale, and electric conductivity. Later on in this video, we'll also add another one, which it is not added here because of some specific reasons. So if you check on the second one, we have said universal indicator and a pH scale. It means each of them alone cannot work to determine the strength of an acid or a base. So we'll start with a pH meter. What is a pH meter? So a pH meter is a device used to measure the strength of an acid or a base. It means if you are given a solution of acid, either acid or a base, you can be able to detect the strength using a pH meter. So in this slide, we have a diagram of a pH meter with some labels. So this is how it looks like. So here we have some electrodes. Here we have a screen which is able to display some pH values. So how does it work? Here is where we need to understand properly how does a pH meter work to determine the strength of an acid or a base. So the substance to be tested, here it means if you have solutions either of maybe you have two acids or two bases, you want to know which one is strong and which one is weak base, and you are using a pH meter, it means the first thing is that you need to put the substance in different beakers. That's what I'm saying. Put the solution to be tested in separate beakers, and you can still label them. Dip the electrodes of pH meter in the solution. Observe and record the values. So the values that you can record from different solutions, you can put it in a table for proper comparison. So after you have recorded it fully and properly, you compare the pH values of the solutions tested. So how do you know that this one is strong or weak acid? So the solution with the high pH values is either a strong acid or base, depending on the solution that you are using. You can only test the strength amongst only the bases or the acids. Not you can test, maybe you have two beakers where the other one is an acid and the other one is a base. It will be a little bit difficult for comparison sake. So here, if you can check, we are saying acids and bases. It means you can have solutions of acids only. You want to test the strength, and you can also have the solution of bases where you want to also check on their strength. Now, the second one is pH scale. So a pH scale looks like this one. So what is a pH scale? A pH scale is a standard color chart with pH values. A pH scale does not work on its own to determine the strength of an acid or a base. Later on, we are going to look at how it works, because here the statement is saying that it does not work on its own. It means it needs help somewhere else to determine the strength of acid or a base. So if you can check the pH scale, it has different colors, and these are pH values. And here it is saying acidic, it means starting from 6 up to 0, it belongs to acidic solution, while 7 is a neutral substance. Starting from 8 up to 14 represent alkaline solutions, which are bases. How does a pH scale work? It uses universal indicator, which is used to determine the colors of the solution. After that, you can compare the colors of the solution on the standard pH scale to obtain the pH values. So let us look at an example. Describe how you can determine the strength of two unknown acids with the same concentration. We want to know its strength. So the aim of the experiment is to determine the strength of acid. Materials that we need beakers, we need universal indicator, we need pH scale, as well as a dropper. Procedures that we can follow to determine its strength. So you measure reasonable amount of the acids to be tested and put it in two different beakers. Label the beaker A and B, add 2 to 3 drops of universal indicator to the solutions, and observe the colors. After you have observed the colors, compare the colors on standard pH color chart. Record the pH values. So you can record the pH values in the table like this one. From there, you can have some comparison and make conclusions. So if the pH value are between 0 to 3, it means it's a strong acid. While when the pH value is between 4 up to 6, it means it's a weak acid. Note the same procedure can be used to determine the strength of bases. So if you use the same procedure, maybe you are determining the strength of two bases. So if you find that the pH values is between 8 to 10, it means that one is a weak base. And if it is between 11 to 14, that one it means it's a strong acid. So after, how do you do that? So this is an example of a pH, standard pH color chart. After you have added your universal indicator in a test tube, you can see here the color of solution has changed. You start matching to the colors of the pH, standard pH color chart. Where the color resembles, then it means you know that this one, using the pH, you know the solution, its pH. So if it is like this one, it means you can get the result from here, that is a pH value. From there you can know the pH and you can determine the strength as either a strong or a weak acid or bases. The third one that we can use to determine the strength of an acid or a base is electric conductivity. Electric conductivity, an electric circuit is used to determine the strength of an acid or a base. So you have a circuit somewhere else which you use to determine the strength of an acid or base. But how do you determine using electric circuit? So electric circuit contains electrodes, connecting wires, batteries, as well as a bulb or an ammeter. Here we're saying as well as a bulb or an ammeter. It means you can use either of them, not both. When you want to use a bulb, you can just choose to use a bulb. So this is a diagram of electric conductivity with connecting wires. So we have battery here, we have a bulb, we have a switch, we have electrodes. So they are dipped in a solution. So for example, describe how you can determine the strength of an acid or a base using electric conductivity. The aim of the experiment is to determine the strength of an acid and base using electric conductivity. Materials that we need beakers, connecting wires, electrodes, bulb or ammeter, cells, acid solutions. So you set an apparatus as shown below. It means you connect the connecting wire, the bulb, the battery, and the electrodes the way it looks here. From there, you are going to dip the electrodes in the solution. After dipping the electrodes in the solution, you start with the solution A, then you close the switch and observe what is going to happen to the bulb if you are using the bulb. If you are using the ammeter, you still observe what will be happening to the ammeter. Then you record the results in a table. So if we are using a bulb, in this case, we are going to look at the brightness of the bulb. Because remember, one of the properties that we said of acid is that they are able to conduct electricity because they have ions. So if the solution is weak acid, the bulb will produce dim light or no light. But you'll be able to see that electric current is able to pass through. How do you know that the electric current will be able to pass through? You'll be able to see bubbles around the electrodes, showing you that electric current is able to pass through even though there is no light. While if the solution is if it is a strong acid, the bulb produces brighter light. Note, the same procedure can be used to determine the strength of bases. Same applies to whatever we have been doing with acids. You can also use the same with bases. That's why we're saying that the same results will be obtained. If it's a strong base, we expect to have more brighter bulb, but if it is a weak base, we expect to have dim or no light. Using magnesium ribbon. Remember I said in the previous we only mentioned that we can only use three ways to determine the strength of acid and the base. But this one, it can also be used only when you are looking at the strength of an acid, not a base. That's why initially in the previous phase rights, we did not include as a way of determining the strength of both acid and bases. But this one can be used to determine the strength of an acid only. We use magnesium ribbon. For example, again, let us look at this question. Describe how you can determine the strength of an acid or a base using magnesium ribbon. We can only determine the strength of an acid, not a base. We can only determine the strength of an acid, not a base. So the aim of the experiment is to determine the strength of an acid using magnesium ribbon. Materials, we need a test tube, magnesium ribbon, strip, acid solutions, and sandpaper. The procedures: measure reasonable amount of acids solution and put it in different test tubes. Label the test tube. Clean 2 pieces of magnesium ribbon using a sandpaper. Place the pieces of magnesium ribbon in the test tubes with acid solution and observe what happens to the reaction. It will be observed that if acid is strong, the evolution of hydrogen gas is more rapid, and you can see that maybe the magnesium ribbon will not take time for it to react, and the reaction is more vigorous, unlike when the acid is weak. When the acid is weak, the evolution of hydrogen gas, it will be slow. It means, which shows that it's a weak acid. In short, you will see that the hydrogen gas is coming out slowly. But when it is strong acid, the reaction doesn't take it takes short period of time, and you see hydrogen gas is escaping from the beaker into the atmosphere, as well as you see the reaction to be more vigorous. It's like to be producing a lot of sound, unlike when it's a weak acid, the sound of the reaction will be flat. Application of neutralization reaction. Remember, we looked at neutralization reaction when we were looking at the chemical properties of acids and bases. One of the chemical properties of acid and base, we said, is neutralization reaction, and we defined neutralization reaction as a reaction in which a base neutralizes an acid. And one of the products of neutralization reaction is salt and water. So now we look at the applications, the benefit of neutralization reaction. So the first one will be reducing of stomach acid. Remember, the stomach wall produces acids. The acid is there to ease and as well as help digestion system, as well as sometimes it can be produced more than what is required, where you can have some problem. So if it is produced more than what is required for you, you need to neutralize it. That's why we are saying that the stomach wall produces acids, which is useful for digestion process. Too much production of the acid may lead to ulcers. These are stomach walls, stomach sores, as well as heartburn. Therefore, to neutralize the acid and acid drugs such as andrew liver salt, as well as magnesium trisilicate and magnesium milk of magnesium are used. Initially, these drugs are bases, so they react with the acids which is produced by the walls of the stomach and neutralize it. Excessive, the second one is it is used in agriculture. Remember, in agriculture, we use fertilizers. The fertilizer that we use, it can be either acidic or basic. So it can change or it can tamper with the pH of the soil, which can affect the growth of some of the crops in the field. So for you to neutralize it, if excessive use of fertilizer is used, as well as hard water changes the pH of the soil, so you can neutralize it. If the soil, when the soil pH is low, it means the soil is acidic, and it can be neutralized by adding a base in the soil such as agricultural lime, which is calcium hydroxide, as well as basic fertilizers such as ammonium nitrate. When the soil pH is high, it means the solution is basic and it can be neutralized by adding acidic fertilizers. The third one, it can also be used in cleaning the teeth. When we eat the food, sometimes it is stuck in our mouth, in the teeth. So if it is stuck there, bacteria, remember bacteria, they are all over. They act on the food and they release acid. So if it remains uncleaned, if the acid remains uncleaned in the mouth or remain unneutralized in the mouth, it may cause teeth decay. Therefore, toothpaste, which is a base initially, is used to neutralize an acid. That's why it is advised that after eating, you need to clean your mouth to avoid teeth decay. The fourth one, it is used to treat insect bite. When insects such as bees, wasps, scorpions sting a person, it injects the victim with either a methanoic acid or alkaline solution substance, depending on the type of insect which has stung a person. If it injects with alkaline substance, vinegar, which is also known as ethanoic acid, is used to neutralize the base. But if when it is injected with an acid, sodium hydrogen carbonate, baking soda, is used to neutralize the base. Bar session, remember the meaning of bar session. We said bar session is a quick exercise. The first one is the exercise that you can work on it. The first one is, what is the difference between a strong and weak acid? What is the difference between the strength and concentration of acid? Describe how you can determine the strength of a base using electric conductivity. Describe how you can determine the strength of an acid using a pH scale. Describe how you can determine the strength of an acid using pH meter. Name 2 examples of weak acids. Explain 2 applications of neutralization reaction. This marks the end of the presentation. Hopefully we have achieved our objective. When you have time, go through these questions. If you have some problem in answering the questions, there is some contacts which you can link up so that you can get help. So the resources that will helped us to come up with this presentation, we have Excel and Succeed Junior Chemistry Book 2, Achievers Chemistry Book 2, Target Junior Chemistry Book 2. Then the photos, we have the photos and the video. These are some of the links that you can click and look at the more photos just to add on what we have presented. Thank you. Goodbye.